Students, we are given this question. Find the total number of x lying between this interval 1 less than equal to x less than equal to 2021 that has the ability to produce an integer value for this expression 2x cubed negative 6x squared negative 3x negative 20 divided by 5 times of x negative 4. Now clearly x cannot be equal to 4, because if it were to be equal to 4 the expression vanishes. So we need to avoid x equal to 4 at all cost. Now what I'm going to do is I'm going to rewrite this numerator as a product multiple of the denominator x negative 4. So in fact, in other words, this denominator which we see here x negative 4 is the clue to solving this question. So what I'm going to do, I'm going to rewrite this as the numerator as 2 times of x squared of x negative 4 positive 2 times of x negative 4 positive 5 times of x negative 4 divided by 5 times of x negative 4. Now you might be wondering, how did I figure this out? The simple answer is by practice and trial and error. Now if I were to, just to show that to you all, if I were to multiply the terms 2 times x squared times x, this is going to give me 2 times x to the power 3 negative 8x squared. This will give me positive 2 times x squared negative 8x and positive 5x negative 20. So this is 2 times x to the power of 3. This is going to be negative 6x squared, and negative 8x positive 5x will give me negative 3x and negative 20. So this is exactly what is being given as a numerator. Okay, so having got this, let us proceed on to solve this question. So what I'm going to do, I'm going to take x negative 4 as a common factor and I'm going to place all other terms. So this is going to be 2 times x squared positive 2x positive 5 divided by 5 of x negative 4. Now x negative 4 can be cancelled, so that would give me 2 times of x squared positive 2x positive 5 divided by 5. Now we need to produce an integer. So in other words, we need to find, this is required, we need to find all x such that x is lying between this range and it produces an integer for the expression. So I'm going to rewrite this as 2x of x positive 1 positive 5 of 5, which is equal to, this can be further rewritten as 2 times x of x positive 1 divided by 5 positive 5 divided by 5. Now this is because of the fact that using algebra a positive b over c can be rewritten as a over c positive b over c. So that is why I'm able to rewrite it like this. Now 5 divides 5 once, so I'm going to place that 1 there, followed by 2 times x of x positive 1 divided by 5. Now clearly we know that this is an integer, right? But now the question is solved if either x or x positive 1 is a multiple of 5. Multiple of 5, right? Because if it is a multiple of 5, clearly 5 can easily divide that. So that would mean this is going to be an integer. And integer added with integer will give me an integer. And that value of x which produces that integer will be accounted. Now we will have to take x to be as, let this be case 1. We will have to take x to be as 5 times k. Now if x is equal to 5k, then we will have to look for all x present in 1 less than equal to x less than equal to 2021. Now the first x starts here at 5, the next one is going to be 10, and then 15, and then 20, and so on. Now the question comes, it goes all the way up until 2020, right? Because 2021 is not the value that we would require. So we need to start from here up until 2020, not 2021, because clearly 2021 is not divisible by 5. So the question comes, how are we going to count the number present in this particular set? The answer is simple. We got a formula that Tn is equal to a positive n minus 1 times d, where a is the first term, n is actually what we want. We need to know the value of n, and d is the common difference, that is 5 terms. That's going to be 2020. Right, so let me just find that out. So this is going to be 5 positive 5 and negative 5, and clearly positive 5 and negative 5 gets cancelled, so I've got 2020 is equal to 5n. So this would mean the value of n is equal to 2020 divided by 5. So 5 divides here 4 times and 0 times, and 5 divides here 4 times. So the number of n is 404. So what does that mean? It means we got that many numbers which are divisible by 5. From case 1 we see that there exists 404 x's that can produce an integer value, okay, an integer value for the expression, okay. So this is understood. This is the clear fact from this information that we have obtained. Now there is another case too, or I should say there's a second case. What is the second case? Now if you can clearly see, we said the problem is solved if either x or x positive 1 is a multiple of 5. Okay, that is the understanding. So that should be a multiple of 5. Now what would produce x positive 1 to be a multiple of 5? Now if I were to place x is equal to 5k, definitely it's going to be 5k positive 1, which isn't a multiple of 5. So we need to produce that multiple of 5. So for that, for case 2, x should be equal to 5k negative 1. Now that would mean we need to choose all x. We need all x that produces this value, that produces this value, of course, in the given range. So let me write that down. What is the first value? Now if I were to take k is equal to 1, of course I start with k is equal to 1. I can't take k is equal to 0. So k is equal to 1. If I am taking k is equal to 1, because the reason is this is the range that has been given, or this is the interval we have been given. So if I were to take k is equal to 1, I would get the first value as 4. K is equal to 2. 5 2s are 10. The next value as 9. I will have to go all the way. So I will have to stretch all up to not 2020. I need to go all the way to 2019. So having obtained this, we need to find number of such x's that are existing in this set. So how are we going to do that? By using the same formula. So this term is 4 positive n negative 1 times the difference is actually 5, and the last term is 2019. So I'm going to use this space to perform the calculation. So this is going to be 4. This is going to be 5n minus 5, and 4 negative 5 would give me negative 1. So I got a negative 1 here, and I have 5n here, and on the left hand side I got 2019. So if I were to move this one negative 1 to the left, I would have 2019 positive 1 is equal to 5n. So that would mean I got 5n is equal to 2020. So that means n is equal to 404, right? But we cannot put 404 here. Okay, we cannot put 404 over here and add these two things together. We cannot do that. You know why? We should take away 4 at any cost. So that is a very important point, because when the value of 4 occurs, the expression is undefined, so we don't want that to take place. So the number of x that are present here is actually 403. Now to take up these two cases, so from case 1 and case 2, so let me use this side of the space. So from case 1 and case 2, from case 1 and case 2, the number of such x's is 404 from case 1. That's what we have got, 404. From case 2 it is 403. So if I were to add these two things, I would get 708. So 807. So what is the meaning of this? It means there are 807 x's present in the interval 1 less than equal to x less than equal to 2021 that will produce an integer value for the expression. Thank you, students.